It's good to be back here again. I was here about 3 years back when we were talking of one of the first large-scale deployment of Neo4j at Cisco. So my name is Prem Malhotra. I work for Cisco IT, and my teams, a bunch of them are out here. So what we did in the past was leverage Neo4j for a system that's called hierarchy management platform. That's still going strong and being used. But today I'm going to talk to you about a totally different area, which was on the area of content findability. So when I mean content is unstructured content, documents, files, presentation, and so on. So considering the size of Cisco, 70,000 employees, 40,000 or maybe 30,000 vendors, and documents are really large in number, close to 20 million documents along different repositories. So the typical problem that one gets into is you have good search engines, but search engines are not really giving you the kind of relevance that you need to find exactly the content you want. So the reason we started looking at a subset of our users is the sellers, and you know sellers are very important. I want to be selling them all the time. They have to be spending all their time with the customer. But our sellers were telling us that they are spending close to 40 minutes to 1 hour every day finding the content they wanted to take to their customers. And I don't know how many of you have the same kind of problem in your organizations, but we definitely had one. So the intent was, how can I come up with techniques that will not only help our sellers, but also our bigger, larger roles across Cisco. And when we started looking at this findability problem, we kind of got down to what's the key reason how we can make the search engine do a better job, and what is the missing link, why we can put the best search engine on the job, but still you don't get what you want. So why is the findability problem there? So you look at typical search engine, it has a nice indexer, it looks at all the content in different repositories, and it associates words to document association. And what happens next is the user comes in, and typical users will have 2 or 3 words as their queries. So it's very tight, small request, and the engine is trying to do the best job it can to match the request to the content that it has indexed. And often the case is like when you go to your luggage, to take the luggage at the airport, you end up with a lot of black colored luggage bags, which are hard to find which is yours, and often people start decorating them with different labels or strings or what have you, and that is exactly what they're doing to put in a metadata on the content. So what the problem was, too much of content, no deeper understanding of the content, which means no more characterization on top of this content. And the content is Word files, your presentations, PowerPoints, your recordings, and what have you. And the queries are typically very brief, so one can definitely do a manual tuning of the search engines, and we do that. And they work only for the top queries that you can manually tune. So there's an expense associated with that. And as the content changes, you might go back and retune because your business has changed and so on. So that's a doable technique. We use it, but it's not something that can scale. And the results are ineffective because the context of the user, you can't really get that well with very, very few amount of words in that. So the key reason for this problem that we identified was we need to add metadata to our unstructured content. And you would have noticed that a lot of your content management systems do provide a place to add metadata, but how many people actually put it? Less than 1%. And these are, even if you put in a few words, it's kind of time consuming and people are too busy to do that. So what did we do? So our teams said there are different ways to get to leverage the metadata, but first attempt is to figure out how to get it. Manually, you can read a few thousand documents, not millions of documents. So we have reached to our machine learning and big data techniques, which are fortunately were there at the right time in the right place. and that helped us get a deeper inspection of the content, what is inside it, and be able to extract concepts, which I'll talk more about later, and that forms one kind of metadata that we have. The second thing we did was, let's look at what people do with the content. So it's important to know how well the content is being used. We gave people capabilities to plug into the end consumption point, the ability to rate the content, track how well it is downloaded, used, and did people want to group it in a particular way. All these are very rich pieces of information that's telling you something about the content. So that we characterize that as another part of the metadata. And combining these two is the rich metadata framework that you get. Once we got that, and we were doing all this for the domain across Cisco, but the earlier applications of that were to smaller area of sellers' content. So how did we use this? So if you start on the side of searching the content, the first thing was, when you get all this rich content, can I use it as a tagging mechanism? Can I automatically machine tag your content which is already there in the repositories, or the new content that you're creating? So we did that. Along with that, we provided a very nifty way to provide this governed tagging, which is if they are these content creators like tag doc writers and so on, who do have the incentive to tag, can they do it very effectively? And that's called governed tagging in our space. So next was a thing called query assist for the search. This was leveraging what we learned about the content to be able to help the search engine do a better job. And this has become quite effective, and we'll see it in the future in the other following slides. Now on the right, it was all you're going to look for the content, the conventional search. So on the left is newer ways to get the content, and there have been some talks here earlier on recommending content. That is, the content comes to you. The recommendation in this work is being able to use metadata to bring the right content to the right context of a user. And that has been quite effective for us as well. And then intelligent interactive browsing. This is how can you make the conventional browsing through your documents, the different hierarchies that people use to say how documents are organized, make it smarter that people don't have to go through deeper click-through routes to get to the content they were looking for. And you also only show the browsing that it makes sense. So this is one area that we're still working on. And the kind of roadmap in this direction is that eventually you should be able to interactively tell the user, here's something you typed in, here's another piece that I know because you're looking for Cisco content that you should also be interested in, are you? And if that kind of comes in, that's on a future roadmap in this particular area. So the intent here is make it easier and easier to find the content that you're looking for. And this third category that I call here content type classification, this has something to do with, as our systems are all going to cloud, the security of our content is a very important consideration. Now, how do you secure your content if you don't know what type of content it is? So using machine learning techniques to be able to put a type on the content. This type means this is a product requirement specification, or this is a test specification, this is actual customer feedback, what have you. That is very important, so that then you can apply your content classification policies on top in terms of security and really tighten down the security on only the limited content that you need to. And so in that bigger domain of moving our systems into cloud, this is one of the area we are working on. So in the next, the remaining of the presentation, I'll walk through some of the details in this, what I've talked about the areas, and then kind of conclude with a thing called Sales Connect. Sales Connect is an application that used many of these capabilities that we evolved out of this work, and there's also a demo that goes with it that I'll get to show you. So before we do that, let's look at where the Neo4j kind of comes into the picture. So the heart of our system, where all the information kind of sticks around and gets served or recorded, is a Neo4j database. And if you start from left to and go counterclockwise, the first thing here is the document content repositories that are being processed automatically using big data techniques. They generate concepts, they go in there. Then there's a content rating service, which is like the Amazon style rating. You can rate as well as give comments. Intelligent query assist is helping the search engine. I'll talk more about it. Machine tagging I just described. It is sending a document in real time. It can actually give you the tags which are very useful for finding it later on. Content organization is services that can let experts in different areas say, these all pieces hang together for a particular purpose. So it's almost like saying, I put it in my briefcase, or put it in my, as my kind of, what you do in your browsers, conventionally, how you can organize it in a much easy way. Content browsing, we just mentioned that it's easy to make, easy to browse around. And then content consumption and personalization is how can I localize my application. So when you localize, you have a lot of personal choices that people are making. So we capture that as well in the system. And the content recommendation, we'll talk more about it. This is metadata based content recommendation. So you see everything hangs around the Neo4j ecosystem. So let's start with the ability to find concepts in the content. So what happens here is we leverage document clustering techniques using Hadoop and Spark big data platforms. So start from the bottom up. You get your content in different forms. The first thing is you do a stripping of stop words and things like that. So make it in a form that can be easily represented for a clustering process. And the clustering process uses an algorithm called LDA. There are quite a few options available. We found LDA useful. And the outcome of that is a collection of keywords or phrases that represent a group of documents. So think of clusters of documents represented by these bunch of phrases that you can call a concept. And this is all fed into the database. So here's an example of this architecture block diagram of how the machine tagging works. So what you see below the dotted line is the previous slide I showed, the bulk data processing. And by the way, we kind of processed about 1.7 terabyte of content. You have any question?
Do you use any semantic processing to extract contents from free text?
So most of our processing does use the statistical techniques, but semantics are used for things like, we don't really use the semantic techniques, but we use content cleaning areas. We use language libraries for that purpose. So what you see here in the top left is the real-time service. You can tag a content of a moderate size document in less than a second or so. And how it does work is that you bring in the file in, let's say content management system on the right is the one that's creating new documents. So it sends the document into the service in real time. Once the user says, I'm about to check it in, it's almost done. And what our service does here, that white box on the left top, is essentially do a reverse or almost same thing that you would have done for a lot of documents when you did it in the bulk processing, but now do it in a form that you can do a distance matching of that document to the concepts that are there in the graph database. So we use a cosine distance technique, and out comes a set of tags which look something like this. So what you see on the right is, left is the document, right is you can see the tags with different colors. The colors are just there to highlight the different phrases out there and the words. And so notice one thing here, this is not just giving you words, it's giving you phrases that we have discovered in the content that we associate to this document. Now, in most cases, these phrases do appear in the document. But in many other cases, they might be appearing in collection of documents that all hang together because of our back-end processing. So you might find combination of two things here. Typically about 20 tags is what we keep, but there is no limit. You can ask for a large number of tags as well. So let's say now we did all this machine tagging. What does it help you with? So let's revisit the slide I showed you before. You had the text, and you have the search engine, indexer, and there was a person who was typing in something to be searched for. The difference between that picture and what we do with the tagging is that now we applied on the left the machine tagging. So that was the metadata service that's box. That is the one that is doing this tagging that I showed you in the previous slide. And the tags are kept along with the document. So now what happens? The search engine can do some smart things. Search engine can say, oh, I got more stuff to look at. So I can look at the entire text along with the tags, or I can re-look at the text and the tags as a separate buckets. And the relevancy algorithms have a lot of options to be designed for. You can just do search based on tags. You can do search based on text plus tags. There are all these options available. So that is what gets you the richer index, a richer way to understand what user was looking for. And you get a better matching by the search engine. So the other thing I talked about was query assist, another way to help the search. So query assist was something that we stumbled on when we were trying different things with the content that we had, or the understanding that we had built of the back-end processing. And what we found was that as you look in the right top, if you take the search request and trap it before it goes to the search engine and send it to our system, the intelligent query service, what it does is, since it knows the Cisco content, because we are looking at Cisco content only, you're not looking at the Google kind of audience, you're looking at inside Cisco. So therefore, we know what we understood about the content. We can do a very smart matching of what user asked with this content and identify phrases and acronyms that can then expand the request into a logical expression, something like this. So what you do here in the top, you have got a search request called Internet of Things, application-centric architecture. This is a very Cisco lingo kind of search, because it's talking of Internet of Things that Cisco works in, and application-centric architecture is one of the new areas that we have our kind of solutions built around. So what the middle row here is showing what the query assist did. It applied IoT as acronym along with the Internet of Things, but the important thing is identifying the, under quotes, the phrases. And once you give phrase to a search engine, you have a very different outcome. You get fewer matches which are more effective, more accurate, instead of search engine trying to make a sense of it using other techniques. So this is a way to help it. And what we did was, based on the amount of content that we understood today, which is not the whole amount. We have about 20 million documents. We are probably at 3 million or less. But it hits half the time. Half the time it can actually say, I can do a change. And then we did a A/B testing kind of evaluation to see how effective is it. And it turns out that it is as good as your manual curation of content, which means you can manually, you can tune the relevance to get an outcome. The same thing happens for the same kind of queries almost as effectively as if when it's done by query assist. So this is the last main thing I'll talk about. So content recommendation was done for our sellers. Now remember that we are trying to say, how can I get the right context? So we did first for our selling community. So as you know, most of the companies have their sellers on a Salesforce.com system where they start their day and end their day. They enter their deal information, how was the status of the deals, and so on. So we said, we also have it. Let's go tap it. So once you tap the Salesforce.com system, you know what kind of deals are in the system for each user, and what is the age of the deal, and all kind of other attributes of the deal. So that's the way to get the context. The next was our content. So I said earlier, we tag the content. Some of it could be manually tagged or curated or automatically tagged, and then it is grouped into bundles. Bundles means they're like a collection of 3 or 4 documents which all hang together for a purpose. They're talking on the same topic. and it's typically done by experts. And then the magic of this happens during the matching, which is a smart matching that happens, which uses the deals information and the tags information from the content repository to be able to find out, along with applying the business rules. Like one interesting thing that happened here when we were talking to our sellers, they said, I only need help when my deal is less than 1 month old. Once it has gone past that age, either it has fallen off or it has gone into a more mature state. I don't need any more help from you. So those are the kind of business rules that we were able to incorporate in this smart matching, and the outcome was a few content pieces that they can actually take to the sales call right away. So what does this all look like now? So this is one snapshot from the application. I'll give you a demo on, but that demo will not have this snapshot because I'm not a seller, so I won't get this particular recommendation. And so it's telling you based on your CCW deal. CCW is the internal name for one of the applications like Salesforce that our partner sellers go to. And by the way, we have close to 300,000 partner sellers along with our sellers. So it's a large selling community that this is all targeted towards. So here's telling you, it's giving the documents, there are about 4 documents that it should be looking at for that particular seller. So this is a kind of a bit of a busy diagram, but this kind of sort of brings together the different areas that I talked about. Sales Connect is the name of that application, but this the foundation is used not just by that, but the entire Cisco use as well. So what you see on the left is graph database, which is doing all this smart things I talked about. Then it is very closely sits next to Alfresco. Alfresco is a classic content management system. And next to it is the content management system for web content, which is like the content you see on Cisco.com, the web pages and so on. That comes from Adobe. It's called Adobe AEM. Earlier name was CQ5. And then we also a big user of Box. We have got 100,000 users on Box. And so that content is as well part of our content management platform. So the company of this size needs to have multiple systems, but we have been in the journey of consolidating all of them into these 3 systems. And then the right of that, right of Cisco.com, there's a TVO. This is our new search engine that we deployed, started this journey about a year and a half back, and is doing very well. And the rest, is there to demonstrate the different kind of APIs, which are all REST APIs. So the services that view that we have here is you can consume it from any place at a pretty good throughput. So what I'll do next is give you a kind of sense of this application that I talked about. So give me a moment. And then we can do a Q&A. So this is a Sales Connect application. I logged in from here. Any Cisco employee can get into it. I already logged in. So what you see here, let's say look at things like Global Sales Kit. The Global Sales Kit was one of the mechanisms to converge very related content together. And it has all the tile style, and this looks the same on iPad and an iPhone. So let's say I'm kind of going through this list, and there's kind of you can click on any of these groupings, but let's say I was looking for something caught my eye, like life sciences, for example. So you will see the content that comes under it, and you can go into each of this content and actually provide ratings and so on to it. So this is what, like it kind of tracks how many people viewed it, how often it was downloaded, was it shared by anyone, all that. All this, that's rich information that is coming back to our system. So go back. So now this is the piece that I was talking about, recommendation based on SFDC and CCW. I'm not a seller, I don't get it. So because this is, I'm tapping into the real system that people are using right now. Then we have things like new on Sales Connect. So as the content gets refreshed or redone, updated, and so on, system can get a recommendation to you based on that that attribute of the content. Then here's something interesting. What's trending? So this what's trending is based on the usage, ratings and comments. So it's a evaluation of what content people are finding very useful that you should also look at. So this is not customized to a context, but in general, the richness of the content on the system. And each of these is, click on it, you'll find either the individual pieces of content or they would be bundles of content, depending on, like in this particular case, look at this. It has a very large view count, share count, download count, and so on. So one other thing I want to show you here is a thing called browse by category. So if you remember, I talked to you about smart browsing. So it's something that it does here in the browsing case is you can go through these different categories, but then you can come up with let's say data center and virtualization is one of the groupings of what Cisco does, and you can actually go look at content in the same way. So earlier you were going through your recommendation of the content, but here you can say, okay, is something I want to click through myself and find the content. So in this particular case, all these tighter pieces of content that are coming to you are because search engine is looking at the metadata that goes with the content. So theme of my kind of talk here is metadata is very important for finding the content, and there are several ways to look at and how to apply it. And I kind of talked about a few of them. However, we have just started our journey. There's yet way more to go in this particular area. So I think I'll stop here, and there's a fair amount of time, 12 minutes left, so we can have a Q&A and really, yeah, please.
In your diagram, you showed an ontology.
In your diagram, you referenced an MDS ontology in the text. I'm curious, what is the nature of that ontology, and is it a RDF-AL triple store, or is it something which is simply a model that you use conceptually?
Yeah, we don't use RDF there, but we store it in a graph form. So it's a graph, and it has a collection of this information that we got from the big data processing and the statistical techniques to be able to say, here's the essence of this collection of documents in terms of words and phrases, and then how are they linked together.
So it's an ontology that is dedicated to the content that it was processed. It's not a metadata ontology for content in general.
It represents the metadata of the processed content, and then we also augment it with the human-developed hierarchies, which are part of our ecosystem, like the products and the verticals and so on. Yeah. So it's a mix of the two.
The reason I'm asking is that when people talk about ontologies, you're talking about models of things in general that can be applied to instances of classes, but this sounds like it's more customized to the meaning that's contained in the content. I see.
Correct. Yeah. Please. Yeah.
When you generate the automatic tags, do those get presented back to the original author when they contribute a document to give them a chance to interact with those, to say whether they were right or wrong?
Yeah, that's a good question. So when the tags are generated, what happens is they come back to the user who's checking in the document, and at that point, the user has the option to say, I can take some off, I can take all of them off, and so on. So yeah, they're absolutely in control all the time.
Hi, thank you. Any thoughts on getting into the documents and using partial content from different documents? Has that request come up? Because, for the salespeople, the problem is always new. It's always a new area, and then you may have to assemble content from different documents. So are you using graphs for looking at portions of document?
Right, I think it's a very, very timely question because we are right now in that journey for our tech doc writers. So our technical documentation in the legacy sense was writing these huge frame maker documents, and we still have them. And you give it to a user, it's useless because you're looking at 500-page document, you want to find a small snippet of things here. So where Cisco is moving in that area is topic-based content creation. So once you have topic-based content creation, you actually have ability to characterize it with the metadata, and now you can have a dynamic assembly possible. So user comes in and says, I'm looking information for this particular thing. It's almost like search, but instead of giving you a pre-assembled search document from search, you could actually assemble it all together using the metadata. We are not there right now, but that's the active area of work that we're doing right now today. And other thing to add is this same problem is not just there for sellers. This problem repeats itself through our organization for marketing content and tech doc. I told you the technical documentation content, and the other areas that we are exploring as well. Content is finding it is a real hard problem for large companies.
In your talk, you mentioned about doing some A/B testing. Can you give some references or some examples of what do you guys do there?
How do we do the A/B testing?
Yeah, what are the different approaches that you guys use, and are there any open source tools that you guys use to determine the effectiveness?
I think for this particular case, we did not use the open source tool, but in a marketing group, we do use an open source tool for A/B testing. I don't remember the name. What we did was we turned off the query assist for some content, and then once we turned it off, that content happened to be also manually curated, or the relevancy was manually tuned for it, and so we could be able to compare the results of that. Okay, if there are no more questions, we can stop here. Thank you.